Welcome, everyone, to this explainer. I am absolutely thrilled you're tuning in today because we are tackling what is arguably one of the most pivotal, make-or-break topics in the entire Cambridge 9618 syllabus. Today, we're doing something a little different. We are adopting the mindset of a master sculptor. Think about it. What does a sculptor actually do? They don't start with a perfect statue. They start with a massive, heavy, completely unrefined block of stone. And for us in computer science, that raw, unrefined material is a record structure. It's essentially a custom data type, right? It holds a bunch of related variables all bundled under one single name. But to reveal the masterpiece inside, to craft that flawless A-star exam answer that examiners are actively looking for, you have to start chipping away the noise. You have to aggressively remove all the irrelevant, messy information until only the precise, beautifully structured core remains. That is exactly what we are going to do today with our Cambridge exam strategy. We are focusing intensely on reading data from and saving data to record structures. We're going to completely transform how you approach this topic, taking you from just frantically scribbling down memorized syntax to actually sculpting an answer that commands top marks. Look, there is a massive consensus among senior Cambridge examiners, and it's this. The difference between a solid B and a flawless A-star in computer science, it almost always comes down to how well you understand reading data from and saving data to record structures. Now, I'm not just saying that to scare you or get your attention. It's a literal reflection of how the 9618 syllabus is fundamentally built. You might be wondering, why this specific topic? Why is this the great divider between an average grade and top-tier mastery? Well, because reading and saving data to record structures isn't just about memorizing a couple lines of pseudocode or Python. This is the exact critical point in the syllabus where your theoretical knowledge brutally collides with practical algorithmic application. It actively tests your ability to handle data persistently. If you can master this, you aren't just showing the examiner that you know some cool computer science trivia, you're proving that you actually know how to build, manage, and maintain functioning real-world systems. So here is our roadmap for today's session. First up, theoretical foundations. Second, the procedural framework. Third, we'll look at examiner warnings, and finally, maximizing marks. Okay, let's dive right into this. Section 1, theoretical foundations. Because, let's be real, you cannot build a masterpiece without a rock-solid base. The theoretical architecture of handling record structures absolutely does not exist in a vacuum. You can't just study it in isolation. Mastery here involves three critical pillars. We're talking precise definitions, causal relationships, and crucial cross-topic connections. When you read principal examiner reports, they consistently highlight that top-performing candidates do something very, very specific. They reference those cross-topic connections. They don't just mindlessly write out a record definition. No, they explain the why. They explain how changing a data type within that record, like, say, swapping out a chunky 32-bit integer for a simple Boolean, has a direct causal relationship with memory allocation and the overall file size. They are actively demonstrating a connected conceptual understanding of the whole machine. When Cambridge inevitably throws some weird, highly specific real-world scenario at you on exam day, rote memorization will literally fail you. But if you have this deep theoretical foundation, you can adapt to absolutely any scenario they throw your way.
Now, I really want you to notice the contrast here. A massively flawed approach, and I see this all the time, is simply memorizing a huge block of unrefined facts. That's superficial breadth. You might go into the exam and just write down everything you have ever learned about the type and type syntax, crossing your fingers and hoping something sticks to the wall. But the assessment framework for 9618 doesn't care about your trivia skills. It specifically prioritizes analytical depth. Yes, the objectives target knowledge and understanding, but far more importantly, they are targeting application and analysis. Academic benchmarks for this topic require you to show logical, structured reasoning. The examiner desperately wants to see that you can deeply analyze exactly why a specific record structure is the most efficient choice for saving a particular data set. It's all about precision, not just brain dumping.
Right. Let's keep moving to our next core area. Section 2, the procedural framework. Systematic processing within this topic follows a very strict, highly standardized sequence. Top-tier students methodically move through these exact 5 steps, almost like muscle memory. Step 1. Identify key elements. What exact data fields need to be extracted or saved in this specific question? Step 2. Apply relevant principles. Ask yourself, are we using an open file for read on a sequential file, or are we dealing with random access? Step 3. Execute the analysis with crystal clear working. This is the nitty-gritty where you actually extract the data from binary representations or parse through strings. Step 4. Verify your results. Does the extracted data actually make logical sense within the context of the record's defined data types? And finally, step 5.
present in the appropriate format. This means meticulously ensuring your algorithm directly addresses the specific command word used in the prompt. Skipping around these steps or rushing through them is literally just leaving easy marks on the table.
When we talk about practical application in the exam, what we are really talking about is algorithmic thinking. Developing your programming skills for record structures demands 4 non-negotiable elements. First, step-by-step decomposition, breaking the big, scary problem into tiny, solvable pieces. Second, appropriate data structure selection. This is huge. You have to be able to justify why. For instance, an array of records is far more efficient and logically sound than trying to horribly manage 5 separate 1D arrays for the specific problem you've been given. Third, efficient code implementation. And fourth, rigorous testing. This procedural framework right here, this is your engine. This is what drives you to the top of the mark scheme.
Hey, quick pause. To keep sharpening your procedural framework and stay ahead of the curve, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, we are back. Let's get into Section 3, the examiner's playbook. We are going to look at the exact places where highly intelligent, well-prepared students absolutely bleed marks. Listen up, because there are exactly 3 critical, totally avoidable mistakes that students consistently make year after year when it comes to record structures. If you can just avoid these 3 things, you are already miles ahead of the curve. Let's completely deconstruct these warnings. Trap number 1, using the wrong algorithm for the context. Picture this. You beautifully memorize an algorithm for reading a text file. You write it out flawlessly. But the question specifically asked about a random access file utilizing a hashed key. It doesn't matter how perfect your text file code is, the examiner literally cannot give you marks for solving the wrong problem. Trap number 2, forgetting boundary conditions. This is a classic. When you're reading from a record structure, what actually happens when the file is completely empty? What happens when your EOF, your end-of-file marker, triggers unexpectedly halfway through a loop? If your logic doesn't explicitly account for these edge cases, your program crashes and your answer is fundamentally flawed. And trap number 3, perhaps the most tragic of all, lacking specific context. If the exam question sets up a scenario about a veterinary clinic's database of animals, your variable names and your logic absolutely must relate to that clinic. Writing out generic, razy names like variable A and variable B will get you 0 marks. Context is everything in Cambridge exams. Prove you are solving their specific problem. Stop scrolling. If you want to avoid these traps and boost your great boundaries by 2 or 3 levels, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, home stretch. Section 4, maximizing marks. This right here is how you secure crucial points, even when your algorithm goes totally, horribly wrong. Evaluative thinking is the master key in those higher mark questions, which very often ask you for a comparative analysis between different ways of storing or reading data. The amateur candidate? They only list similarities. Oh, both of these methods store data. Great, thanks. But true A-star comparative analysis requires identifying similarities and differences. You must explicitly use comparative connectives, words like whereas, conversely, or in contrast. You need to support every single comparison with direct evidence pulled straight from the exam scenario, and then, this is the kicker, draw a firm conclusion about their relative importance. Tell the examiner why one method is vastly faster to read from, whereas the other method consumes significantly more memory. That is the exact analytical depth examiners are begging to read. To consistently achieve that level of depth, you have to rely on the deconstruct, solve, evaluate trio. First, aggressively deconstruct the given information in the prompt. Second, solve it systematically, constantly checking your logic for reasonableness. Finally, evaluate and justify your choices. And here is a massive secret that most students don't know. Acknowledging the limitations in your own solution is actually a profound strength. If your algorithm for saving data to the record structure totally works, but you know it's computationally heavy and slow, write that down. Tell the examiner. Make justified recommendations for how it could be improved. That level of professional self-awareness practically forces the examiner to award you top-tier marks. And finally, here is your ultimate lifeline in the exam room. Show you're working. Method marks save grades. I literally cannot stress this enough. So many students hit a wall.
They panic when they get lost halfway through writing some massive complex algorithm for saving data to a record structure. And what do? They take their pen and they cross the whole thing out because they know the final output is going to be wrong. Please, I am begging you, do not do this. The Cambridge syllabus explicitly, intentionally rewards your process. Even if your final code is completely broken and wouldn't run in a million years, showing clear, procedural, step-by-step working guarantees you method marks. If the examiner can look at your mess and see that you correctly identified the necessary data structure, or that you correctly initialized the file reading process with an open file statement, they will give you points for that methodology. Do the work, show the work on the paper, and let the examiner reward your thinking, even if the final destination was a bit off. Well, we have covered a massive amount of ground today. We went through the foundational theory, the strict procedural steps, the deadly examiner traps, and the ultimate lifelines for saving your grade. But knowing it isn't enough. Consistent practice is the absolute only way to lock this in. So make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Now, I genuinely want to hear from you. What is your target grade for 9618 computer science? And what is the absolute biggest challenge you are facing right now with record structures? Drop a comment below right now. Our team responds to every single comment. Like and share this explainer with a study partner who needs to hear this. AC Exams, your Cambridge success starts here. Keep sculpting that perfect answer, and I'll see you in the next session.